We know that as we grow, the hurdles will be more. Each time we are washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. See the Okay, so I'm Shumanto Kundu, Assistant Professor of Department of Electrical Engineering of Narula Institute of Technology. Today we will continue with the module number 5 of the course curriculum of Electrical Machine 1, and we will today discuss the second, or rather rest of the vector grouping of three-phase transformer. Okay, so objective and outcome is to become familiar with the vector grouping of transformer. So let's start the lecture number 3. So we have seen in our last class that this is the different group, and we have already discussed the group number 1 we have discussed so far, and today we will discuss the rest 3 group, that is 180-degree phase displacement, that is 6 position in clock, minus 30-degree, 1 position in clock, and plus 30-degree, that is the leading position, 11 position in the clock. Okay, so now group 2. Okay, so group 2, so this is the winding diagram for Yy6 and Dd6, and this is not in our scope of syllabus, so we will not discuss this zigzag connection. So we only concentrate on Yy6 and Dd6. So look here that this is A to N. So the primary side voltage Va to N, and this is secondary side phase voltage Va1 N. So it is a 180-degree phase shift. Okay, and look here also, it was C2. So this is the virtual star here. So this is C1. So it is also C1 come to this position. So this is the reverse delta. So this is also 180-degree, that is Dd6 connection. So let me explain this a bit details. Okay. So first what we will do? First we will do the voltage phasor diagram. Voltage phasor diagram. And as we have mentioned in our first lecture of vector grouping, that the position of primary side phasor is fixed. That is, it is from a equilateral triangle. So let me first draw a equilateral. Okay. So this is equilateral triangle, and we have mentioned the top position is E2, right position is B2, and this is my C2, and this position is fixed. Primary side, this position is fixed. So now we are concentrating on Yy6. That means high voltage is star connected, low voltage is also in star connected, and position clock position is 6, that is 180-degree phase shift. Okay, so let me draw this equivalent star also. Just wait, give me a few minutes time. So this is my equivalent star position. So this is my primary phasor of star connection. Primary phasor of star connection. So this is A1, B1 and C1 from the neutral point. So this is my neutral point in. Okay. Now, so let me draw the parallelly the connection diagram also. So primary side, there is 3 winding. Let me draw the 3 winding. So this is primary side winding, and look, A1, B1, C1 is short and it from the neutral point. So A1, B1 and C1 is shorted, and basically it form the neutral point. So this is my brought out terminal, the HV side A2, B2, C2. This is the dot notation. Okay. So that means A2, A1 positive. So secondary side also A2, A1 will be positive if the dot remain in this small A2 terminal. Okay, if now, so this is my start to finish. This is my start to finish. So start to finish is positive. So that means finish to start is negative. Finish to start is negative. Now look, we need a 180-degree phase shift. So this is my A to N. So this phase voltage is V A to N. Similarly, this is my V B to N, and this is my V C to N. Okay. So 180-degree phase shift means it is completely opposite to this V A to N. So let me draw the secondary phasor first. Okay. So let me draw the first secondary. So this is my primary phasor. This is my primary phasor. Okay. So this is my primary phasor. So now what I will do? I will draw the secondary phasor. So 180-degree phase shift means it will be somewhere here. So then only this is my 180-degree. Similarly for this phase it is somewhere here. For this phase it is somewhere here. So if this is A to N, so opposite. So A2, A1 is positive. So my A1, A2 will be negative. So this will be my A1. This will be my C1. And this will be my, sorry, small b1. Small b1, small c1. Okay. So that means now this A2, B2 and C2 form the neutral point. So now the connection diagram of the secondary, it is very easy now. So let me draw the 3 winding first. So this is my 3 winding. So now A2, B2 and C2 is shorted. Okay, so A2, B2 and C2 is shorted, and this is forming the neutral point in the low voltage side. So the terminal is basically A1, brought out terminal, load terminal is B1 and C1. Okay, so this is my dot here. So A2, A1 is positive, so A1, A2 will be negative, so it will be in opposite side, which gives me a 180-degree phase shift. Okay, so this is my Yy6. This 2 is, this 1 and 2 is 1 and 1 dash is my voltage phasor diagram. And this 2 and 2 dash is my winding connection diagram. Okay, so this is, and the clock diagram is very simple. You draw your clock, you keep the minute position in 12 o'clock, which is fixed position, and keep the hour hand in 6 o'clock position, so which gives my 180-degree phase shift. So this is clock diagram. So 3 diagram I have drawn for Yy6. Now it is the part of draw Dd6, that is delta delta 6. Okay, so let me draw a Dd6. D, sorry, small d 6. Okay, so again what I will do, I will draw the primary side phasor first. So let me draw a equilateral triangle first quickly. So this is my equilateral triangle. So this is my A2, this is my B2, this is my C2. Now this is delta connection, and the equivalent star is this. So this point where A1, B1, C1 form the virtual neutral. Okay, so this is A2, so this is A1, so this is B2, so this is B1, so this is C2, so this is C1. So let me draw the winding diagram of primary side first. So this is one winding, this is the another winding, and this is the third winding. Okay, now these are the brought out terminals, so A2, B2 and C2. Now connection is A2 C1, so this is my C1, B1, A1. So A2 C1, so this is the connection. Okay, now what else? B1 C2, so this is my another connection, B1 C2. And what is B2 A1? So this is my B2 A1, and from here the terminal are brought out, A2 B2 C2. So now look, this primary side voltage phasor diagram, primary side winding connection diagram we have done. Now we will draw the secondary phasor diagram first. So in secondary phasor diagram, so it will be a opposite delta, so it will be a opposite delta. Okay, so this is my star, so this is my opposite star connection. and this delta is also the reverse delta. Okay, so now what will happen? This is my small a1, because I have discussed this a2 a1 is positive star connection, so a1 a2 is negative 180 phase shift. So this is a1. Similarly, what will happen? This is b1 and this is my c1. So if this is a1, this is my a2. If this is b1, this is my b2, and this is c1, so this is my c2. Now let me draw the winding connection diagram. So let me draw this first winding, then second, and this is my third. So in secondary side, the load terminal brought out from A1, B1 and C1. Okay. So what is my connection? B1 A2. So let me quickly keep the terminal name A1 A2. This is B1 B2. This is C1 C2. So A2 B1. Okay, let me connect this. This is my A2 B1. Now A1 C2 B2 C1. So let me connect B2 C1. Okay, so this is B2 C1, and then A1 C2. Okay, so let me connect A1 C2. Okay, and terminal we brought out from A1 B1 and C1. Okay, so this is 1 dash is my voltage phasor diagram, and 2 dash is my winding connection diagram for Dd6 vector group. Okay, so this is the group 2 vector diagram. Okay, so now let me move into the group number 3. So let me move into the group number 3. Okay, so wait for a bit. I hope whatever I am teaching you is clear to you people, and is my communication English language is also is well enough to make you people understand. Okay, so now move to the group 3. So move to the group 3, and this is my 1 o'clock position. 1 o'clock position. Okay, so in 1 o'clock position, so in 1 o'clock position, so this is my group 2, so this is most probably group 3. Yes, this is group 3. So this is the group 3, that is we will discuss dy1, yd1, and zigzag is not in our scope of syllabus. So look here if you consider, so this is my secondary line to line voltage A2 B2, and here this is my A2 B2. Okay, so this angle is 30 degree. Okay, so this is my A2 B2, and this is and this is my A2 B2. Okay, or else we can take the neutral voltage also. We will get the same minus 30 degree phase loop. Here also this is true, and accordingly this is the winding diagram. Okay, so let me draw in details. Let me draw in details. So first we will draw this. Let me draw first dy1. Okay, so let me first draw dy1. So primary in delta and secondary in star position. So what I will do, again I will draw the phasor. So let me quickly draw the equilateral triangle. So same procedure. It is the most effective way to build your concept on vector grouping. Okay, this will be a straight line, no matter. So this is A2, this is B2, and this is C2. And inside this, this is my equivalent star. This is my equivalent star. Okay, so again A1, B1, C1 form the virtual neutral. So this is B2, so this is B1. Okay, so this is A2, so this is must be A1, and this is C2, so it will be C1. Okay, so let me quickly draw the high voltage side connection diagram. So okay, so now A2 B1. So give me the name of the terminal. A2 A1, B2 B1, C2 C1. So A2 B1. So let's connect this A2 B1, B2 C1, B2 C1, and then A1 C2. So this is my A1 connected to C2, and the terminal of the high voltage side is A2 B2 and C2. Okay, so now let me draw the phasor diagram, so which is star connection. So the delta connected equivalent star is this. So let me draw the star connection first. So this is my primary side delta equivalent star connection. Okay, okay, so color combination will give you a better idea, so that's why I'm doing this. So now look, this is neutral terminal, so the phase line to neutral voltage is V A2 N, and secondary line to phase voltage is V A2 N, and with respect to this will be in 30-degree lagging position, means clockwise rotation. So in primary or high voltage, this was A to N. So clockwise rotation will be give me minus 30 degree. Simple mathematical, simple like mathematics. So in 30-degree position, let me draw this phase. Okay. So this is my A2 and this is forming my neutral. Okay, so this is A2, this is was B2 for A2 and this was C2. So now B2, so clockwise 30 degrees. So very simple. Okay, so this angle is 30, this angle is 30. Okay, so hope you people are getting interest. Okay, and similarly for this also in 30-degree position. So somewhere here, this is my small C2. Okay, so now this is my dy1 connection. Now in this figure, so this is my line to line voltage, that is B2C1, or we can say it is A1 B2, both are same. Okay, and this is forming A1 B1 C1 neutral point. So what is my B2 C2 now in case of low voltage side? So this is my, so sorry, let me draw somewhere here also the same way. So uh, so actually I am not very good in drawing. So this is my small A2, this is small B2, and this is small C2. So this is my B2 C2, and here this B, where is this B2 C2 in? So it will be parallel to each other, I have told. So this is actually my B2 C2 here. So for this is for high voltage side B2 C2, and this is, so this angle is basically you look 30 degree. So in phase to neutral, line to neutral also 30 degree, and we have checked with line to line voltage also, line to line voltage also. So this is dy1 connection. Okay, so this part you will draw with this scale, it will be a better picture. Okay, so forgive me, so I am not a artist. So now let me draw that YD1 connection. YD1 connection. Okay, so now the last one of this third group, YD connection. Start delta transformer. This is a start delta transformer with 30-degree lagging position. So let me draw this equilateral triangle first. So I'm trying to improving my drawing. Okay, so but drawing, so it's important to understand the logic, which is the most important thing than drawing. So I hope I am drawing with that much perfection so that you can understand the concept. Okay. So it is a star connection in primary side. So this is A2, B2, C2, and as usual A1, B1, C1 form the neutral. Okay. So let me draw the winding connection diagram first. Okay. So Proto terminal is A2, B2, C2. So this is A1, B1, C1. Connect this with this and this with this, and this is forming the neutral for star connection. Star connection. Now secondary is delta with minus 30° phase shift. Okay. So minus 30°. So it's a very simple way is to draw in this fashion for this one connection or 11 connections. So this is A2, so this must be A1. So let me draw parallel to this. Okay. Or else what we can do, so this B2 C2 is my line voltage. Okay. So let me draw this B2 C2 first. So B2 C2 is high voltage side, line voltage. So the secondary will be in 30° lagging position. That means clockwise rotation. This means clockwise rotation. So clockwise it will rotate and 30° position. So it will be somewhere here. So it will be somewhere. I'm improving the drawing, right? So this is somewhere. So this is my 30° lagging. Low voltage will lag in 30°. So this will be my small B2 and B1. So we know for delta connection B1 is connected with C2. So this is my C2. So this is my C1. Okay. Okay. So this will be the my arrow. Here the arrow will be this, and this is the closing arrow. So this is C1. So this is must be A2. So this is must be A1. So now I have completed that 30° phase shift. Okay. So let me draw the secondary winding diagram first. So this is winding 1. This is winding 2. This is winding 3. Okay. So this is my A2, B2, C2, A1, B1, C1, and A2, B2, C2 is the brought out terminal, broadside brought out terminal. Okay. So now connection let A1, B2. So connect A1, B1, C2. Connect B1 with C2 and A2 with C1. So connect A2 with C1. So this is my YT one connection. Okay, so we have taken this B2C2. Similarly, this is my line voltage A2C2. Okay, so this is my line voltage A2C2. Okay, so secondary side, this is my A2C2, and this is my primary side line voltage. So suppose we consider somewhere here is primary side A2C2, so in 30° this. So similarly, this is A2B2 is my line voltage A2B2. So this is my A2B2. Okay, so it will be somewhere here also. So in this fashion we can draw the so better consider one line voltage P2C2, draw it in 30° clockwise position. You put the secondary line to line voltage, then we will get the terminal. So if this is B1, we can easily say this is C2. If this is C2, so this is C1. If this is C1, this is A2. If this is A2, this is A1. So the delta is completed. So this is my YT connection. Okay. Now the last one is my group 4 connection. So I think this is group 4. Yes. So this is my group 4 connection, that is the 11 position, means 30° leading position. 30° leading position means plus 30°. That means anti-clockwise rotation is positive. You have to keep that in mind. So YT1, DY11, YT11, and according to look, this is a 30° plus phase shift is occurring, and according to these are the winding connection diagram. So let me draw the DY11 and YD11 in details for your better understanding. Okay, so first DY11, first DY11. So again the same thing, equilateral triangle. So this is my equilateral triangle A2, B2 and C2. Okay, and inside this is my equivalent star connection. Okay, so this is my A2C2, this is my A2B2 line to line voltage, and this is my B2C2, and V A2N is my line to neutral voltage. So let me draw the winding diagram first. So A2, B2, C2 is the bottom terminal. This is A1, B1, C1. So this is A2, so this is A1. Okay, so this is B2, so this is B1. This is C2, this is C1. So connect A to C1. So connect A to C1. Connect B1 C2. Connect B1 C2. Connect A to B1. sorry, this is wrong. Connect A1 and these are the brought out terminal. So let me erase this terminal. This is not correct. Okay. So 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 this is the connection A2, A1, B2. So A1 is connected with. So primary phasor, voltage phasor diagram and primary winding diagram is complete. Okay. So now let me draw the secondary, that is star connection. Okay. So look, this is my delta equivalent primary star. Okay. This is A2, this is B2 and this is C2. Now we have to give a phase shift of 30 degree plus, means we have to rotate it in anti-clockwise rotation, then it is plus 30 degree. So this is A2N. So secondary A2N will be somewhere here, somewhere here. So this is my A2. Okay. So this is my primary side VC2N. So somewhere in 30 degree position here will be my low voltage side C2N. So and this is B2. So we have to similar ways somewhere we have to draw 30 degree position. Suppose in 30 this is my 30 degree position. So this is my B2N. So this is my B2. So this is the equivalent star connection of low voltage side A2, C2, B2. This is 30 degree lead, 30 degree lead, 30 degree lead. Okay. So if we join these two terminal, so this is my line to line secondary voltage V2, C2. And what is my primary side line to line voltage? This is V2, C2. So this is my primary side line voltage. Okay. So to look there is exist a 30 degree leading position. So if you want to catch that secondary phasor, you have to move 30 degree anti-clockwise. So that's why it is plus 30 degree of leading position. Okay. Now draw the winding connection diagram. Very simple. So A1, B1, C1 shorted. So let me short this terminal A1, B1, C1, A1, B1, C1, which form again the neutral point, and this is my A2 brought out load terminal B2 and C2. So this is my DY11 connection. So this is only one left. The last one is let me draw which one I left, YD11. Okay, so let me draw the YD11. So primary star, secondary delta. So let me draw the both the winding first. Similarly, secondary side also 3 winding. Okay, and quickly give me the name. So this is suppose A1, B1, C1, E2, E2, C2, A2, B2, C2, A1, B1, C1. Okay, so this is the thing. Okay, so again equilateral triangle. So let me draw the Phasor. I am not drawing the triangle, I am directly drawing the star connection. So top is A2, right is B2, and this is my C2. So again A1, B1, C1 from the neutral. Okay, so connect. So A1, B1, C1, and this is forming the neutral point, and this is the proto terminal E2, B2, C2 of the three-phase supply side or HV side. Okay, now so this is A to N, C to N, B to N. V A to N is the line to neutral voltage. Okay, so what will happen? It will remain in 30-degree leading position, secondary phase. So this is my B to C2. Okay, line to line voltage is B to C2. So let me draw that first. So this is my primary line to line voltage B to C2. Anti-clockwise rotation is positive, so somewhere in 30-degree position in anti-clockwise way, here it will be the secondary B to C2 line to line voltage. So somewhere here, somewhere here. Okay, so now easily we can get the terminal. Okay, so this is my small B2, this is my small C2. Okay, so if this is my B2, so let me draw complete the triangle first. So I can easily draw the triangle now. Complete the triangle. So this is small C2 and this is B2. So if this is C2, this will be C1. So B1 C2 terminal we have completed. So left I have to detect that A2. So if this is B2, so this is must be B1. So here must be the A2 terminal. So this is my A1 terminal. So what is connection? A1 C2. So A1 C2. So A1 is connected to C2. Then B2 C1. So B2 C1 and A2 B1. A2 B1 and A2 B2 C2 are the brought out terminal. A2 B2 C2 are the front of terminal. Okay, so this is all about our vector diagram. Okay, so this is by dy11, and previously we have drawn that dy11. I hope this is my dy11. So in dy11, what we will do, we will draw the secondary phasor diagram first for our ease of drawing, and from secondary we will draw the primary, and then we will draw the winding connection diagram. Okay, so thank you. I hope you have understood everything the way I have taught you. But still, further, if you have any queries, feel free to communicate with me. I'm providing my email ID. Okay, thank you.